Alrighty, I think we're good to get going. So we're moving on now to classes. This is one of my favorite topics in object-oriented programming. Um, this is going to be really weird for a little bit. It'll take a little bit of practice getting used to classes because it's a very different way of programming than we've been doing this entire time, which is it's good and bad. So um, we'll practice it. We'll have lab on it today. We'll do more practice. The project will use classes, and it'll be a lot of fun. So this um, as a little bit of a caveat, you don't need classes to solve problems, right? The languages that are object oriented use classes because they're object oriented languages. The reason we like classes is because it's very natural for people as we talk about how we solve problems to use classes because the way that we're used to interacting with things is we understand nouns. So like if I say, hey, I was sitting at a table, when I say table, you probably have a picture in your head of a table. You probably know it has some legs. It probably has a certain color, made out of a certain material. Maybe it's wood or it's plastic or whatever it happens to be. Uh, you think of all the attributes that that noun has, right? And that's how we think in real life because that's how we interact with things. So what classes let us do is turn nouns, not always nouns, but generally nouns, into a block or chunk of code that we can interact with, like we would interact with things in the real world. Now, this table is kind of boring. Maybe chair is a better example. When I say chair, there's all sorts of different kinds of chairs. Some of them have wheels, some of them don't have wheels, some of them go up and down, some of them don't go up and down. Some have arms, some don't have arms, right? Some can tip back, some can't tip back. So all sorts of attributes of chair. They're all chairs, but they make them distinct. And then I can say, hey, I have 30 chairs in the room, and each of them could be a little bit different if I wanted them to be. Now, most of your chairs are all the same, but mine is awful and makes this really terrible squeaky noise all the time because I hate this chair. But that's okay. It's supposed to go. It doesn't even go up and down, does it? It's supposed to go up and down. I don't know. There's the lever. There we go. Look at that. Oh my goodness, that goes way high up there. That that's crazy. I'm super excited though. That was fun. Now I can like swing my legs like a little kid. All right, maybe I'll sit like this. Am I still in the video? Okay, I'm still in the video. Just an awkward angle. This is fun. So when we think about how we would interact with things. You can do things with them, like the verbs, the things that they do, like go up, go down, tip forward, tip back, these sorts of things are verbs. Those are things that we can interact with that particular noun with. So let me fire up PyCharm here, and we'll start working on one. And then we'll see how we can use this class to sort of define and interact with the chair. Do a new project. This is what, chapter 9. Chapter 9. Chapter 9. All right, this is a little too high. There we go. Okay, chapter 9 for classes. So classes are used to let us make reusable code, generally that relate to a noun. So and we'll look at all these different fun things we can do with classes. So if we were to write a class for chair, right? I know usually classes start with an uppercase letter. So we kind of change our convention up a little bit here. So classes will typically have an uppercase letter to start, as this indicates they're a class, not something else. So a couple things about classes. So when you make an instance of the class, we're loading one of these things in memory, and we have to give all of its attributes values here. So to do that, we have a special method called init, so initialize, and it takes this attribute called self. This is automatically given, which is super cool. So self is the current instance that we're talking about. So that way I can have 30 different chairs, and I could paint each of them a different color. Imagine I have my box of crayons, and I'm just going to go color each chair. I could do 64 chairs, right, with my 64 colors of crayons. I could have them each have a unique set of their attributes, right? Because each chair actually exists and could be different, even if they all started the same, right? Some of the wheels might be stuck, or some of them might be a little bit broken here, or whatever might have happened, right? So init is used when we create a chair, create a new instance of chair, and it gets loaded in memory. So all of the attributes that we want to belong to chair, we're going to say are self.attribute. So self.color is, I don't know, how about we assume chairs are black? And self dot, how about has wheels? We'll say is false until we know otherwise. How about self dot height or height of seat maybe? Seat is what's the default? Is it like 30 inches? Or how many? It's like 80, 90 centimeters or so. Height of seat in centimeters, right? Probably 90. That might be too high, right? I don't know how much it is. It doesn't really matter. That's okay. So uh, let's say this one has wheels. We'll say it's true here. The height of the seat in centimeters, and then self dot. How about we have a minimum height here? So the lowest I can lower my chair, if I want to go all the way down, I'm pretty low now. I'm probably like, and this is in centimeters here. We'll say maybe this is 30 centimeters. So I'm more than a foot off the ground, right? Probably 45 centimeters, like a foot and a half off the ground, maybe. And then how about a self dot maximum height? Maximum height in centimeters. We'll say maybe that's 120 centimeters, maybe centimeters. There we go. Love how it spell checks me here. If I go all the way up, I'm like way off the ground here. I got to stand up to even sit on this thing here, right? All right, there we go. So maybe 120. We're making up the numbers. They don't have to be exact. So we'll say we probably start at 90. You can go down to 45. You can go up to 120, right? 125. There we go. So it has a range of 90. Let's just make some fun numbers here, right? Okay. So these are things about the chair that we know. So every time we make an instance of chair, now it will be black. It has wheels. It has a height. It has a maximum height. It has a minimum height. These sorts of things here. So to use chair, then I'm going to say this is Eric's chair. Eric's chair equals chair, and then I'm going to use a set of parentheses. So this set of parentheses here means it's going to call the init method. Right? This call the init method. All of them? This is the init method. So this method, function will run. Sorry, we call them functions. Sorry. This function will run when I say chair parentheses, right? Then what I can do is I might be able to say Eric's chair dot. When I put in dot, I'm going to get access to all of the functions and attributes that are defined in chair. So I can say, hey, let's change my color. Maybe it's not black. Maybe it's actually, oh, it is black here. What if I want to change it? How about we change it to blue? Because I like blue. We'll change the color of my chair to blue. So I can set the attribute, changes value of the attribute, right? And then maybe I make Jeb's chair. I can make a chair for Jeb. Jeb's chair equal to chair. Now, what's cool now is in memory, there are two distinct chairs, right? Eric's chair has one set of values and Jeb's chair has another set of values. So maybe if I wanted to print all the details here, I might be able to print Eric's chair, and then maybe we print Eric's chair.color and print Eric's chair.height in centimeters and print Eric's chair.has wheels. Sure, something like that. And then we would print Jeb's chair. Now, my son Jeb, his chair has wheels is going to be false. His chair at home does not have wheels because he would just be spinning around like crazy in that thing. So we gave him a chair without wheels. Sure. And this will be Jeb's chair. So this is Jeb's chair. And now Jeb's chair dot color, Jeb's chair dot height, and Jeb's chair dot has wheels. So by using the different object that I have here in memory, right? This is one variable. This is a different variable. Right? It's going to access mine versus his. And they're both loaded in memory. So let me actually run this in debug mode here so you can see. I'm going to put a little breakpoint in, going to put a breakpoint in and hit the debug instead of run. And I can see there are two objects here in memory. So this one is loaded this location in memory. This one's loaded here in memory. Yeah, we don't really care about memory addresses, but I see there are different chairs in memory. And it knows it's a type of chair. It's a chair object. So it's an instance of the chair class. So the class code we write here is essentially a blueprint that says, when you make one of these, here's all of the things it knows about itself. Here's all the attributes, right? So I can expand these out and I can see all the attributes. So I can see Eric's chair color is blue because now I've painted mine blue. Jeb's chair is black. His does not have wheels. Mine does have wheels. The heights are all the same. We haven't touched any of those now, right? Those sorts of things. So, and then if we want to look at console, right, we've printed out the details. Printing is not the most interesting thing here, but we can. Is that a question?
Yes, how do you call the function like meters?
So init gets called when you say chair parentheses. This calls the init function by default.
So how did you run your chair and practice function called?
So,
As no business street thing.
so yeah, so by using the name of the class here, this calls the init method. This is just a convention. So when you say, hey, I want one of these, it calls the init method. Yep. So we've done some of these before, but we just don't usually use this weird syntax here. We've used some classes. So trying to think of which ones let's see, which ones have we used here? We did, I think we did it in some of the random ones, right? That was none of those. I'll find one we've done before. So all we've done now is work with attributes. It's not super interesting here. So the next thing we would do is we'd add more class functions. So functions that interact with chair, like how about a raise or lower seat maybe, right? Maybe we have a define, and then we're going to write a function for, how about change height and change height. I'm sorry?
What about the new function?
So init stays, right? This is just how we create the instance. It sets up all the attributes here. So the init method is job is to give values to all of your attributes. You want to have default values or something here, right? So that all of our attributes are known and listed. Because it'll be weird to try and add attributes later. It'll cause all sorts of trouble. So init's job is to load this object in memory, to initialize it. How do we create a chair and have it ready for use in memory? Well, we gave it a bunch of defaults here. So to change the height, again, self is an automatic attribute. We don't need to worry about it. What self lets it do is say self dot to get at all of its attributes of itself. We'll get to more advanced fancy things later. But for now, self is always there. And then if you want an argument to the function, you just comma separate. We say, how about new height in centimeters? So if you want to change the height, you have to tell me the new height in centimeters. Right? We can do that. So I'm going to say, okay, self dot height of seat in centimeters, right? Get my current attribute here and assign it a new value. Assign it the value of this argument here. So you tell me what the new height is, and I will change my self dot attribute. So this is my instance's attribute here. So I can change Eric's chair's height, or Jeb's chair's height, or your chair's height, or their chair's height, right? Any chair I have, I can use this new method called change height and interact with it. Now, what it also lets me do now is add some bounds around what's happening with this object, right? We still have to obey the laws of physics here. I'm pretty sure it's impossible to have a negative height, right? Your chair can't go into the ground, right? So, and we've actually set a minimum and a maximum height here. We said chairs don't go lower than this or higher than this. So once I set the attribute, I'm going to go check it here. I'm going to say, hey, if my self.height is less than the self.minimum height, then I'll set my self.height to the minimum. If you tried to go lower than the minimum, I'm going to pretend like that didn't happen and put it at the minimum. So by the time the function is done, sorry, by the time the function is done here, we'll be at the minimum. So you said, hey, I want to lower to negative 50. He said, oh, sorry, you only get to 45. That's fine. And I can check the same thing with the max here. So if the height is greater than the self.max, height in centimeters, then self.height is equal to self.max. So if you went above the max, let's set you the max. And really, this could probably be an elif here, because if you went less than, you definitely didn't go higher than. Right? We'll save one slight operation here. So checking to see. So this is a sanity check of the argument, essentially. So is the new height within range? If you tried to go way too high, you said, hey, I want to sit 5 meters high. We're just going to tell you, no, it doesn't work. You can sit at 125 centimeters. Right? We kind of silently check. So what this lets us do is protect our objects to make sure that they stay within what we've set as a valid range. And this is huge, right? Anytime we're working with objects and we define them, we get to say this is the valid range here. We'll make sure that someone else doesn't change the value to something improper. Now, this follows a couple object-oriented properties here. So when you talk about object-oriented programming, there's a couple fun technical terms they throw around. The first one they throw around is encapsulation. Encapsulation is a fancy word for putting it all into one nice little package. I'm going to take everything about chair and encapsulate it into the chair class. Right? Take all the details here and put them in a nice little package here, class. Right? So I don't need a class for chair to do these things, right? I could say Eric's chair color, right, is blue. Oh, goodness, blue, right? I could say Eric's chair has wheels, right, is true, and on and on. Like I could have a set of variables for all of these things, but can you see why having a single instance of chair is a little bit easier for us than having five variables for every time I want to have a chair? Right? It's repeated code. That's what functions let us do. We get to avoid repeated code. That's nice. And then it's easier for us to even think about too when we start trying to solve problems here because I understand chair, right? Chair makes sense to me as a noun and I understand it has attributes and I understand the ways I interact with chair. I've got a little lever here to go up and down, that sort of thing. We don't need to use them, but it's going to save me time, energy, and effort. And then I can start encapsulating all those details together. And when it's encapsulated here, I can then also protect the integrity of my class. So we've encapsulated, let me see if I can add some notes here for that. See if I can find a good spot here. Encapsulated all the details of chair into the chair class. Can protect the chair attributes to be within valid ranges, these sorts of things, right? Now, the way that that works is, I can say, hey, how about Eric's chair dot change height to 500, and this will stop it at 125, right? So then I can print Eric's chair height. We should see that it does not go above 125, right? What we'd expect it to do, because it should stop at 125. Now, what I can do though, right, I can say Eric's chair dot height of seat and say 500, right? And then I can print it out. So because I have access to those attributes, I can give them bad values, right? So what we really want to start doing now is we want to start protecting our attributes. And the next keyword here when we talk about classes comes into play. It's called abstraction. Abstraction is a big fancy word for you don't need to know the details, right? Well, if we import random, let's go back up the top here, import random. If I just say print random.randint, 1 to 100, this works. I don't know what this, I mean, obviously we can go look at the code. I think we looked at it one time and it would look like garbage, right? We don't need to know what it does here. So we get to work with functions abstractly. We don't know the details. Abstractly. Abstractly? I think that's probably spelled right. Right? So when we work with chair, when we write a function for chair, we don't need to tell the users the details. They don't need to have all the details. Now, other things, when you say random dot, you don't get access to all the attributes, right? These are all functions here. So typically what we do when we write classes is we have private attributes with public functions. Now this gets to be a little funny. In Python, nothing's actually private. In other languages like C# or C++ or Java, you can make things private where physically the user can't access them. Python is trusty. It assumes you won't do bad things. So what you do in Python here is you mark these attributes that you want to be private with an underscore. Now, color, you can change the color of a chair, so it doesn't need to be private. It's okay to change the color of your chair. Yeah?
I think what would be like 5?
I'm going to show you in a second. So I'm going to say, how about the height of the seat in centimeters is private? I'm going to put an underscore here. So using an underscore uh, denotes the attribute is private. What that means is don't touch it. So if I come now to Eric's chair, right, and I say Eric's chair dot, I don't see the height of the chair. So if you put an underscore there, it's hidden. It's no longer available in this list here because that's the convention in Python. If there's an underscore, you're saying it's private, please don't touch it. Now, I can go touch it, right? I can go, let me go grab these. I can access them directly if I add the underscore back. It is there, right? And we can go do these things here, right? We can go print out the height, we can print out the height, these sorts of things here. Let's give it a run again. Oops, random dot, sorry. Run. Right, we can still go do these things. But because we've marked it as private here, it's even warning us saying access to protected member, height of seat in centimeters of a class. It's telling us you've done a bad thing here. You shouldn't do this. Now, Python doesn't stop you from doing it, but essentially it's one of those like, hey, if you open this part of the box here, the warranty is void. if you start messing with private attributes, protected attributes of a class, you can't expect it to do the right things anymore. You voided the warranty. So when we write classes here, we're going to mark things as private that we don't want people to mess with directly because we're trying to protect them, right? So this idea, so we don't want to do these things here, right? Is that you use the public function. So I'm going to define a function here for change height. This is how you're supposed to interact with the height, right? And then other times you typically have a set of functions here called get and set. So we're going to define a get height of seat in centimeters. Oh my goodness, right? And then again, the self attribute is the default given. It's always there. So just let self be there. So I'm just going to return the self.height. So now they have a way to get this value back out here without having to print the private attribute here, right? We shouldn't be doing this. So if you want to give users access to give the values, you give them a get method. So we have get height in centimeters. Get height in centimeters. So this is the convention. You have get methods. Now you might also have set methods. That's a pretty common convention. In Python, maybe not quite as much, but in other languages you'll probably see it. So we'll do it with color, or we'll do it with wheels. No, we'll do it with color. So let me mark color as private here, and then we'll add get and set methods here. Or I should be able to say generate, implement method. Nope, come on, generate. Does it not do it for me? Seriously? Where's my... Okay, that's really obnoxious. I thought it did it for me. So we'll say a get color returns self.color and a set color. So if you want to change the color here, I'm going to give you a set method. You need to tell me what color you're going to set it to. I'll say my self.color equals the color, right? So now you have public functions that essentially give access to the private attributes. So these set and get methods have lots of fancy terms. Some people like accessor and mutator. You're accessing the value and you're mutating the value or changing the value. I like set and get because they're much easier to say. And then what do those people call it? What's the other term here? I'm not remembering it off the top of my head right now. But there's another set of terms here which are super weird for these. So to set values or get values. That way, for every instance of chair, you can go get the value out and you can set the value. So a good practice here, our best practice, is to have all private attributes with public functions to set get as appropriate, right? So this sort of thing. So let me make another class here. So let's do a class for, how about a car? We'll define in the init method here. So cars have a make. Now, if you want arguments, right, to your init method, you can. So I can say, hey, give me the make, give me the model, and how about a color? So you tell me what, it's a Chevy Bolt that's gray, or a gray Chevy Bolt, right? Any order you want here is perfectly fine. I'll set the make to the make, I'll set the model to the model, and I'll set the color to the color, right? Now, once you have a car that has a make and a model, is that ever going to change? Like, is your car ever not a Chevy Bolt? No, it's not. Like, it doesn't change. So it doesn't make sense to have these have set methods. You don't have to have a set method just because you have an attribute here. But color, you can paint your car, right? So we're going to define a get make function, returns self.make, a define get model that returns a self.model, a define get color. Let me just copy get color. I don't want to redo those. So get color and set color makes sense because you can change those things in your vehicle, in your car, right? You can change the color of your car, but now we're giving public methods, public functions to have access to these attributes here. So once you make a car, right? So I might say Eric's car. Oops, no caps here. Sorry. Eric's car equals car, and mine is a Chevy a Bolt, and it's gray, right? So now if I say Eric's car dot, I get set color, get make, get model. I get the public functions that I wrote, and I don't see any private attribute. Yeah.
So this thing, chat, bold, and gray are like arguments for these functions?
Yep. So these are arguments to the init method, or the init function here. Sorry, this one up here. So if you want someone to have to give you these things when you make a car, we make them arguments to init. So that way you can't make a car. There's no defaults. There is no default make, model, and color for a car. That doesn't make any sense. Now for a chair, we could say, yeah, it's a 45 centimeter chair with no wheels and black. That's probably makes sense to have a default chair. Maybe. It's up to you when you write your program. If you want them to give you arguments, we list them here, right? If you don't, then you don't. You just don't list them. You just have the self here. So it's totally up to us when we write our classes here. How do we want the user to create these instances? Right? How do I think someone's going to use it? Now, writing classes here is how libraries get built. So like random is a bunch of functions. That's fine. Most of the time we write classes, and you start getting further and further in Python, all the libraries you're going to start using use classes. You create instances of these classes and you do cool things with them, which are super fun. So being able to write classes and give them to people to use makes sense. And what the way that you give them to people to be used is you have the public functions, right? So later on, when we start doing machine learning sort of things with Python, not in this class, sorry, we don't get that fancy yet. Um, it's abstract. You don't need to know how it works behind the scenes. Now, hopefully, a lot of the things are open source. You can go and look at it if you want, but we don't need to know the details. We just say, hey, I'm going to fit to curve, and it will fit your data set to a curve. Magic. Sort of, right? It's a black box. It's abstract. You say, go do this, please, and it does the thing it advertised, right? We have functions that do things for us, which is super cool. It does what's advertised. So that's how we start building out these libraries of code that we start sharing around, is because we can build classes and they have functions. So you use the public functions. It's going to have all sorts of internal private attributes that you don't want to mess with, right? We don't want to change any of those things. We just want to use the public functions. So we write classes that are blueprints so that you can create instances of these cars. So if we do my wife's van, right, we can make a new car here. That's a Ford Transit, and it is they call it blue jean color. I thought it was blue jean was the color of the blue, not just blue, but blue jean, like blue jeans. I don't know. I thought that was a funny color. That's my wife's van. It's awesome to drive. It's a big tank. It's 12 passenger. It's fantastic. We got to lug around all the kids and my daughter in a wheelchair, so we got a lift put in, which is super cool. It's a great van. I love it. I don't get commission if you buy Ford Transits, but they're great cars. They're vehicles. All right. So I can make multiple instances here. And again, each one of them has its own set of attributes here and its own set, the ways that we can go and interact with it, right? The verbs, the things that your nouns do are your functions, your public functions, and their attributes, all the things about them, right, are private attributes. Now, other things you probably do with car, right? So car probably has an odometer. Odometer, right? Probably starts off at 0. And again, let's say this is in kilometers, right? Because we always want to specify what the unit is here. So other things you do with car, you might drive. You might have a number of kilometers here. So we're going to say, hey, let's go drive. And let's take our self-odometer and let's add the number of kilometers to it. Yeah. What am I returning?
Yeah.
So this returns whatever the value of make is for this instance of the vehicle. So when I do Eric's car, I can print Eric's car dot get make, right? And we'll go to the Eric's car instance, find the attribute self make, and return that one, which will be Chevy. Right? For Jasmine's car, it would be Ford. For Jasmine's van, it would be Ford. So if we put this in debug mode and run it in debug mode, no color here. That's right. That one's gone. There's share color, no color there. Try that again. Nope, I want a debug mode. Shoot, debug mode. There we go. So Eric's car.getMake. So I can see Eric's car here has protected attributes of color, make, model, and odometer. I can see what they are in debug mode. And if I step into my code, so I don't want to step over, I'm going to step into my code here. I'm in the getMake function, right? I'm in getMake line 15 now, and I can expand. So self is Eric's car. Now, I just know it is self in this function, right? That's the argument we have here with self. Here's the attributes here. So self make, then, it's going to return Chevy. I can print that out. Now for Jasmine's van, right? And when I go to Jasmine's van get make, if I step into that one, self now is the Ford Transit. This self is it's essentially the variable that you've passed here. So when you say self, it's essentially this. So it substitutes the variable in for it, because that's the instance that we're working on. This way you can have 50 different cars in memory, and they all have their own unique set of attributes. Right. So objects are a lot of fun. Classes are a lot of fun. They'll cause a lot of headache though, because it's a very different way for us to write code, right?
What is the actual abilities?
Everything we're going to do is going to be with classes. So they let us organize our code in a more human way. Yep. And then the reuse is there as well, right? We're going to group all these things together, so I don't need to have 5 different attributes that I'm passing around in a like a dictionary, right? We did a dictionary of dictionaries for our last lab, where we had the student and the student had assignments and assignments had scores, right? We're going to do that today with classes, and it's going to be amazing because it'll be one thing, right? You can have an assignment as a class with attributes for possible score, total score, and actual score, right? And then you might have student, and student has a list of assignments, right, as an attribute. And then you might have a grade book that has a list of students. Right? Anything we can rewrite these things as classes, and they're easier to use because they give you public functions to do things rather than having to have a dictionary of dictionaries of dictionaries or what all your keys are and all that nonsense. So it does make life easier for you.
Also, not using dictionaries for this.
You can, right? You can have dictionaries of things, but we're gonna try and make this be a little easier for us. So we'll look through how we can convert those over. Yep. All right. So there's my car there. Yep. So the odometer. So when you start driving the car here, right, we should increase the odometer. Now, the other thing we ought to be careful of is that the number of kilometers should be positive, right? You can't reverse your odometer. That'd be a bad thing to allow to happen in cars. So if that's what we want to model in our code, let's pretend like we're the real world here. We can add that in. We can say, hey, if the number of kilometers is greater than 0, right? Don't give me a negative number and make me actually reduce the number of kilometers on my odometer. That would probably be illegal. I guess it's only illegal when you sell it, right? To fake your odometer result. I think you can do it on your own if you want, just for you, but you can't sell it with a bad odometer. I think is how that works, right? I feel like that's probably the rule. I don't know. So again, we'll put some protection around this here, and then we need to have a get method, right? If this is marked as private, we need to give them access to it here. So we can define a get odometer, odometer here, returns self.odometer in kilometers, right? Now, the other cool thing you can do, right, printing all these details out is kind of annoying here, like the has wheels and the get height and all these things. So you can write functions that take classes as arguments. So I might have a function like print car that takes a car argument, and it's going to print car.getMake, print car.getModel, oops, get model, print car.getColor, why car.getColor, and print car.getOdometer. I probably should pretty these up here, right? This should be make and model and color and odometer. Odometer. Right? So now if I want to print out that vehicle, I don't need to call a bunch of prints every time here. I can just say, hey, let's call the print car, given Eric's car. Let's call the print car, given Jasmine's van. Right? So you can take a class, an instance of a class, and pass it as an argument. So to give you all of the attributes, I don't need to write a function that takes 5 different things. I can write a function that takes one argument and pass an instance of the class there for you. And I can see, hey, here's the Chevy Bolt, here's the Ford Transit, and then we can start driving these things around, right? So I'll print, let's call Eric's car.drive, and it's, oh my goodness, 30 miles to get here. So how many is that in kilometers? 1.6? 0.6 is a little more than half, so like 47 or so. We'll say about 47 kilometers to drive here to campus. Probably close. Right? It doesn't need to be exact, right? And we can see my odometer now is 47. It was 0. Now it's 47, right? I've driven my vehicle. So the ways that I interact with it here work with it here. Okay. Other things about vehicles, right? Other things that happen when you drive, right? You need to make sure you can actually drive that far. So in my case, it's an electric car. Thank you for all paying your taxes and the tax credit on electric vehicles. Uh, so I need to add some other details here, right? So I might say, let's change this here from car to electric car because that's very specific here. So we'll add in now we have a max kilowatt hours in battery. Now, I don't know what that is, so I'm going to take that as an argument, a max kilowatt hours in battery. But that's different for each vehicle, right? And generally, the bigger, the more expensive, the bigger the battery it is. Those sorts of things apply. Kilowatt hours in battery, right? And then we'll set that as whatever the argument is. Great. And then I'll have a self dot current kilowatt hours in battery, right? How much is currently charged? I'm going to say it's zero. So every new car comes with a dead battery, empty battery, right? I don't know if they actually ship batteries or not, or if they make them with charge. I don't know how any of that works. So I'm just going to pretend they always start empty here. So I'm going to add then a method for charge that takes a kilowatt hours to charge. I'm going to take my self.current kilowatt hours of battery, and I'm going to add the kilowatt hours to charge. And I'm going to make sure I didn't go over the max, right? And then I can say if my self.current kilowatt hours is greater than my self.max kilowatt hours, we'll say, hey, pretend like you stopped here at the max, right? Just like the chair height. Don't go over the height. Don't go over the max here. Great. Right, stop there. So I'm going to plug it in and charge up to whatever my max kilowatt hours of the battery is. Right. Other things I need to know here, self dot, let's say, how about kilometers per kilowatt hour? Kilowatt hour is probably an argument here of kilometers per kilowatt hour because that's different per vehicle. And actually, it's different for weather and other circumstances, but let's pretend like that's not the case because that gets too complicated here. Right. So I'm going to have even more attributes here. Now I don't have any of the gets here, right? So I need to add more get methods again, which is super exciting. Define get max, let's get kilometers per kilowatt hour, turn self.kilometers per kilowatt hour, right? I thought there was a way to automate this. Let's see, PyCharm, right? Get functions. Is there not? No? Okay, that doesn't have it here. Auto generate getters and setters? Uh, doesn't have it. Prop life templates? There's a plugin here. Nice. Let's see. Honestly, I thought there was a way to do it, but maybe not. Uh, property decorator, that's fine. We'll get to that later. Okay, that's fine. They don't have it. But properties is probably a little more proper here, but it's not a concept we really get into until later. So we'll come back to that later. So we'll just keep on doing this in slow way and writing our own here. Current kilowatt hours in battery. Uh, turn self dot current kilowatt hours in battery. We also need the max. So this gets to be really tedious here, real quick here, right? Get max kilowatt hours, return self dot max kilowatt hours. Okay, so we've got all the gets. Now, again, I don't want someone to go and just change these values, right? I want them to use charge. I want them to use drive. Now, the other thing drive should do then, right, is make sure we actually had enough charge to drive, right? So if it's a positive number, let's check the arithmetic. Now I can say, okay, if it's positive and my number of kilometers is less than or equal to, right? Or I can convert this either way. So let's say self dot current kilowatt hours of battery slash there. Nope. Yeah, current kilowatt hours in a battery. Oops, I don't need the parentheses here. Sorry. Times the self dot kilometer per kilowatt hour. Right. If you've got 5 kilowatt hours in the battery and you get 10 kilometers per kilowatt hour, you can go 50 kilometers, right? So we're going to check, is that the correct amount here, right? Or we could do the math differently. It's okay. Either one's going to be okay. So if we're able to go that far, right, we have that we have that amount of charge in the battery. Let's go ahead and take that out of our battery. Let's take our current kilowatt hours of battery and subtract from it. Well, this one is reverse. It's the number of kilometers divided by my self dot kilowatt hours of battery, or kilometers per kilowatt hour, divided by kilometers per kilowatt hour, right? If you want to go 50 kilometers and you get 10 kilometers per kilowatt hour, that means you need 5 kilowatt hours, right? We'll reduce the battery by 5 kilowatt hours. This is just arithmetic, right? Nothing too crazy here. All right. So we're checking to make sure that worked. And then if that worked, maybe we say return true, right? Otherwise, we can return false and say, hey, it didn't work. We didn't do it. You wanted to drive too far. We're not going to let you. Those sorts of things, right? We've got a couple options here. So if you want to take your fancy new Tesla and take a road trip across the United States, you don't go from the West Coast to the East Coast. You don't have the charge for that, right? You have to stop at a charging station and stop at a charging station, stop at a charging station, right? You have to plan it out so you can drive little chunks at a time and then charge, drive a little chunk and charge, drive a little, I mean, same way with a gas car. You have to stop at gas stations, drive a little chunk, stop, drive a little chunk, stop, this sort of thing. So we can now give people ways to interact with this here. So if my drive works here, so I need more information here. So let's get rid of Jasmine's van because it's not an electric van. They're making electric transits, so I was super excited to hear about that. But only the commercial type, not the passenger type, which is pretty sad. Like, because they want to compete with all the new electric, like Amazon vans. Who's making those? There's a company in Plymouth that does it. Do you remember the name of them? Oh man, what's their Plymouth, Michigan, Plymouth, Michigan Electric Van Company. They make trucks, right? I think is it Rivian? Rivian? And Amazon van? Yeah, Rivian. So they make the truck. You might have seen some of their trucks on the road. They make passenger trucks, right? Or for people, not commercial, right? I don't know what the word is. Personal trucks? Wow, I've got no words today. But like these Amazon vans are commercial, right? Whatever that difference is here. Yeah, so everyone's trying to do these EV delivery van things, which is sort of cool. So Ford's getting in on it. Not my passenger van, which is sad because I would love to have an electric passenger van. Uh, alas. Okay, so anyway, so Chevy Bolt Gray, I need to tell it then some more details, right? And this is electric car now. Electric car needs, what other details here? What's next? Come on, help me out here. Come on, tell a sense. It's not working. The max kilowatt hours of battery. So I think mine max kilowatt hours in battery. Let's see, what is 250 divided by 3? No, times divided by 3? Probably 83. Somewhere around there, because I can get about 250. Oh, that's 250 miles though, times 1.6. 0.6. All right, 133. Let's say 133 kilowatt hours. Why not? And then it probably gets about 5 kilometers per kilowatt hour. They get about 3 miles, 3 point something miles. Yeah. All right. So now I should be able to drive 47 here, right? Uh-oh. It didn't change. Well, I forgot to charge it, right? If I don't charge the car, it won't let me drive, right? We checked in here for drive. It says, hey, if you don't have the charge in the battery, return false. It didn't work. We don't change your odometer. You didn't drive anywhere. So we got to charge it first. So before we drive, let's call charge. Eric's car.charge. Let's charge, I don't know, say 150. It should stop at the max of 133, right? We can also we can add that to our details if we wanted. So let's add in the current kilowatt hours. Current kilowatt hours. And car dot get current kilowatt hours of battery. Right? So we should see now the battery has been used, right? To go 47 kilometers, we used some of the battery. Well, I guess we should charge it first before we print that out. So let's charge it first before we print Eric's car. There we go. So we started with 133, right? We drove 47 kilometers. We're down to 123 because we get 5 kilometers per kilowatt hour. It's just a little bit less than 10, a little bit less than 10. So none of this needed us to have code for electric vehicle, right? We could have done this all with lists or dictionaries and done all these crazy things, but then like you'd have to have a method for drive that takes a dictionary for car, that you have to look up these different attributes of, here's the dictionary, key of kilometers per kilowatt hour, dictionary key of this, key of, you see how that might get kind of messy pretty quick, right? It's doable, but this puts a lot nicer names to things, right? So much easier than a dictionary to do these sorts of things here, which is really fun. Simplified chained expression. How do we simplify that? Oh, look at that. If zeros between, that's a good suggestion. Do you see it do that? It was telling me I could simplify this. I love it. That's so much nicer, right? Zeros greater than that, greater less than this, all chained together. Very fancy. All right. One dynamic. What is dynamic? I don't know what that means. Sure. All right. So we made our electric vehicle, right? We can charge it. We can drive it. We can see if we can get that far or not. I should get back if I try and drive. Oh, we already did the drive before we charged it, and weren't able to drive that far. So we get those sorts of details. Does that make sense? All right. It's definitely a weird way of working with code. This is brand new here. Um, And everything we've done so far, like we're calling methods and printing out to the screen. I don't know if I called it out very well. Like I expect to see this to show up on the screen. I expect to see this show up on the screen. I expect to see this show up on the screen. I kind of eyeballed it to make sure it was right. Then like as I wrote the code, I ran it to see if it was giving me what I expected, right? It should have worked. It should not have worked if I didn't charge it, right? If I did charge it, I knew it should take about 10 kilowatt hours, right? A little bit less than 10 kilowatt hours. So my battery went down a little bit, right? Those sorts of things. So in order to write your code and to be able to know if it's working, you need to know what it's supposed to do. As we're breaking down the problem from a big problem into smaller problems, right? Like the small problem I'm solving here is how do I make sure I've got the right number of kilowatt hours, right? And then how do I change my odometer, like kind of two in one here. You could break it up into smaller problems if you wanted, that sort of thing. Uh, we could do that. Now, remember we did Connect 4 for our lab? Remember we did Connect 4? We could write that as a class with public functions, right? Instead of having to pass around this list and have all these things. Do you want to do that as another example? That one's kind of fun. Let's do that. Let's write a class for Connect 4. Remember which lab that was? We go level 1. Lab 4? Aha. All right. So here's our board. Let's take all of this here. Oh, let me just redo this here. So make a new lab 4, new project, lab 4 with classes. Okay. So again, nothing needs to have classes, right? This totally works without any classes, right? But what we're going to do now is turn this into a class so that I have just public methods that I can interact with here, right? So I'm going to change this up a little bit here, right? So I shouldn't need board, right? Because we're going to get rid of that. We're going to move board here. I don't need current player. I'm going to say, how about, game equals connect 4, right? And we don't have that class yet, but that's fine. And then while not game dot is over, we're going to write a public function called is over, right? And then maybe we'll say game dot make move here. We don't need any of this, right? And then how about we game dot print maybe? Make a move, game dot print, make a move, game dot print, make a move. Right, this is not super interesting here, but like if we were to try and break Connect 4 down into how do you interact with Connect 4 without knowing any of the details, right? You ask if the game is over or not, and then you make a move. That's about all the public interaction you have with a Connect 4 class, right? If we think about how we would turn that into a noun, what public functions we'd have, right? We can do that. So we don't need current player, don't need any of this board stuff. All right, so let's move all this out. So now I'm going to change all of this and put it all kind of in a class here. Let's go all the way to the top. We're in a class for Connect 4. We're going to define my init method. So init doesn't need any arguments here. To make a new game of Connect 4, they always start out blank. So init will have a self.board, and I'm going to make that private, right? I don't want anyone else to have access to it here. So we're going to say self board, right? We'll set up the empty board here, right? And then all of these methods here, did someone win horizontally? Did someone win vertically? Did someone win diagonally? Did someone win diagonally down? Did somebody win? is tied, is game over, print board, make move. Those are all functions of the class here. So I'm going to add self to all of these. So I don't need the board anymore, right? Because I have self.board, right? I have my instance of board. So I could set up 5 different instances of Connect 4 and play a simultaneous game. I could play against, or 6, I could play against all 6 of you at once, right? And have 6 different boards loaded in memory if I wanted, right? So now this gets to be a little funny here because now board, where else are we using board? I think that was fine there. We didn't anywhere else here. So this is self here. So now it's self.board. So we just have to do a little bit of subbing here, of fixing this up here. I could do the find and replace, but I'm almost worried it would do too much here now. Okay, so this is self, and we want self.board again, right? Self-board, 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 self, self-board, 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 self-board. This is getting really boring here, I'm sorry. Self. And now these are all methods, right? Self dot did someone win horizontally, doesn't need any arguments, right? Self dot self dot. And actually, all of these, you can mark functions as private as well. So all these are probably private functions because none of these we should give public access to. If you look at Connect 4, we don't need to say, did someone win horizontally? You can just look at, did someone win, or is the game over, essentially, right? We're going to define all of these as private. Private, private, and private, right? So all those get marked as private. Why is this upset here? Row. Oh, it should be row index, right? Row index. Oops, row index. No wonder it's red. Look at that. Sometimes the red lines are good. Right, is tied. That's my self.board. Is game over, right? Given self. Is self dot did someone win? Is tied is private. Did someone win is private, right? Or self dot is tied. Print. I think we just said print. Yeah, how about just print? Oh, we can do print board. That's fine. Print board. Now print board, right, doesn't need an argument because it has the attribute, right? Self.board, underscore board.
So we're pretty much changing from the function file to classes.
So we're making them class functions so they interact with an instance of Connect 4. Because that way I can have a bunch of different Connect 4s in memory. With my previous version, you can only have one game at a time. Because I only had one instance, one variable for board that I worked with. Right now I can load 6 different Connect 4 games and play all 6 of you at the same time, or like one after another, right? I can have my board and your board and their board and his board and his board and her board all in memory at once. Because I've got the class for it, so I can load that many of them. Oh yeah, make move even prints the board. That's right. So we don't even need. I guess that's fine. We'll get rid of that print step here. So make move is self. We don't need to know the current player, right? Because we're going to track that ourselves. So in init, now we'll also have then self dot current player is X, right? And then after we make a move, then we can change that. So self.board again here, self.board, self.board. So once we did our move, then, right, we can take our self.current player and change it. So if my self current player is equal to X, then self.current player is equal to O. Otherwise, self current player equals X, right? Oops, go down the line. Right, we can change the player ourselves and make moves. It always changes the current player. So things you might want, we might want to add a get current player. We could if we wanted, right? It's not doesn't hurt to do that. Define get current player, current self dot current player. Right, we could do that. Or make move. Do we want to tell them whose turn it is? Right, X's turn or O's turn or something. We could do that, right? We could print self dot current players. Let's append in here, right? Apostrophe S is turn, right? And then we get their input, this sort of thing. Is game over. Is game over. There we go. We call it is game over. Print the board, make the move. Print the board, make the move. Let's give it a run. It should work here, right? The same. All right. X's turn. Where do you want to go? You want to be X or O?
What?
You want to move? You want to be X?
I feel one.
Well, so remember, we just give it the column number, right?
Zero.
0. Okay. All right. I'll go in column 4. Where you want to go? Okay. I'll go in 3 as well. All right. I better go in 1 to block your 4. Okay. Where you going? 1. All right. Let's see. I'm gonna go in. Let's go 0. Okay. I'll go in. Let's go 0 again. 3. All right. I'll go in 0 again. All right. You blocked me. Okay. That's fine. I'll go in. How about 5?
One.
Okay. I'll go in 1. 3. All right. I better go in 3 to block you.
Two.
2.
Yeah.
And I'll go in 2 and I win. Boop, 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 boop. I forgot to print the board one last time. So after the game is over, we'll call game.print board. But I went in 2, right? I put mine here. Right? So it still all works here. It doesn't look functionally different yet, but now what I can do is I can have more than one Connect 4, right? I can track more than one of these games at a time. So maybe I have like a little correspondence game set up where people use mail anymore now that stamps are so expensive. Like you'd mail your move to a player and then they would make your move and they'd mail their move back to you. And correspondence chess was a thing. I don't know if people ever did it with Connect 4, but you could play correspondence chess. That was kind of fun. They have daily games now on chess.com. If you folks are chess fans, I like playing chess. I'm not very good at it, but I like playing chess. My mother and my brother are rated in the U.S. chess something or other, chess league, chess federation or something. Um, it was not as fun for me because I always got beat by them, so I never wanted to go to tournaments. But they had fun going to tournaments. I forget where you look up ratings. They're inactive. They haven't played in a long time, but they were rated at one point. I don't know if you ever lose your rating. I don't think you do. All right. So let's Connect 4, right, as a class. So it didn't change much functionally here, but right, we now have these private attributes. So we don't have to be passing the board around every time because Connect 4 has the self attribute of its board. So each instance of Connect 4 knows about its board, knows the state of its board, knows whose current turn it is, right? So we have more of a self-contained, we've encapsulated all those details together. So all my functions don't need to be given the board. All my functions don't need to be given these things here, right? It can act on its own attributes every time. So it better encapsulates it here. That's one of the ideas is you encapsulate all the details and people work with it through abstraction. There's just 2 public functions, right? There's get current player's turn and make a move. I'm sorry, is game over, print board. We got a couple public functions, I guess. So 4 public functions, right? Make a move. Most of the details happen here. Now, someone who wants to play Connect 4 can just take our class and call make move, right? They can just do this loop here, right? Over and over and over, this sort of thing. The other really cool thing you get to do now, right? Now that this class is a little bit more separate, I guess, right? We can reuse it more places. Now, make move is not the best example of that because we're telling it where we want it to go. That's not great, I suppose. So it might be better to separate the output here. So generally classes, you don't want to deal with input. That starts to get really messy here. So we can break this out to make this class more reusable. So let's change that. So let's take make move and let's take a column attribute, right? So we're going to take out the column attribute here. And we're going to say if my column. Now, I'm not going to do that. I'm going to return false. Say, hey, it didn't work, right? If you try and make a move and the column was bad, I'm going to tell you false, it didn't work. Otherwise, we're going to return true. So at this point here, this part of the program can go and get that input here, right? So it can say int or column equals int of an input, right? Column number to drop a piece in, right? And we probably want to print then game.get current player uh, is turn. So what we want to do here is we're trying to separate out the input from the class. So if we can get the class completely separate from typing in at the console, it'll be more reusable here. So make move given the column. And then if make move, I guess maybe if not here, right? If we get back a false, we print invalid move, right? We can do that. So let's try this. So let's see if that works for us here. So if I give it something invalid like -1, it should say X's turn invalid move, right? X's turn. Why is it printing that every time? I think we don't want that. Let's see. Oh yeah, let's get rid of that print here. We'll get rid of the prints. Sorry. Try that again. Rerun it. Okay, so X's turn, we tried -1, and we're told invalid move. X's turn, how about 0? All right, that worked. O's turn, 0. It's working okay. 0, 0, 0, 0, 0. And now we get invalid move, right? We're getting invalid move every time. So this is pretty nice. So if we look then, there shouldn't be any input happening. Why is this too many blank lines after? Okay, sure. Shouldn't be any input happening in the class here. Too many blanks, too many blanks. That's fun. That's okay. Sure. Just trying to get rid of all those lines here. They're a little distracting. Okay. So the next step now of this, because this class is fully self-contained, it has all of its logic on its own, I don't have to use this class with console input, right? I could build a graphical user interface in Python that interacts with Connect 4, right? And lets me play Connect 4. Now, I guess printing the board's not ideal. Maybe we give this back as a string. So maybe print board. The next best thing we can do is instead of printing here, we'll get how do we call like get board here. Now this is a little bit improper. You'd actually we haven't got to it yet here, but you're going to define this as string. So to convert something to a string, you use this presents instance of the class as a string. If we're not printing the row, we're going to self.join a new line character with what do we want for row? I do the self join. So not for row in for row. Why is this not working? String object's not callable. We want a string of row. There we go. I think this is what we want here. String object's not callable. Remove call? Nope, that's not right. Oh, string join, comma, string of row. We're getting there. Hang on. Trying to remember how we join these things. Not self.join. String.join, right? Nope. Nope. Oh my goodness. I don't remember how to use Python anymore, folks. I'm sorry. Join this. Okay. Take this character, join together these things here. And we did join a while back. Sorry. Takes a minute here. Got to jog the old memory. So now I can say instead of print board, I can say print game. Right? Because game then will call this string function here. Right? Automatically calls the string method or function. Right? Let's try that. Oh goodness. Print given game. Return non-string type. None. Uh-oh. Oh, I have to return this. Sorry. I've missed the return keyword. There we go. Okay. So now we've got it as a string. Now I've completely separated prints and inputs out of the class. Now we can turn it into a graphical user interface program. Now we can turn it into a web application. Mobile's a bit of a stretch on Python. You could turn it into a calculator program. There's a super cool calculator, NumWorks calculator. NumWorks calculator has a Python shell this calculator can run Python, and it's like TI-83-ish, 84-ish, something compatible, and it's cheaper than a TI-83. Like it's only $100, right? Instead of whatever outrageous. How much is a TI-83 or TI-84? 120 now for a TI-84. Usually 150. Yes, they've been making these calculators since I was a kid. There's no reason it costs $120. It's not that hard to make these calculators, I promise you. Right? You can buy a cell phone for 120 bucks, right? And you can go to desmos.com and run your all your TI-83 stuff, 84 stuff. So Numbworks is pretty cool, and they've like added cool things to it. So I thought that was kind of fun. Anyway, so here we have our class for Connect 4. So now that it's completely separate from input and output here, I can use it other places, right? It adds to the reusability of this class, which is super cool. Because how many people do you know that use console programs? Do you ever like come to your black screen and hit enter and then type a bunch of stuff in? Very rarely. Like some people in IT, that's probably more common here, but generally, most users don't do this sort of thing. So if you wanted to sell a Connect 4 game, you're not selling a console-based game, right? There's no interface, nothing to click on, nothing cool, no exciting graphics. That sort of stuff just won't work for you, right? So we've encapsulated all the details here. We've given you public functions to use, the abstract way to interact with it here, right? Taking away all the details. Oops, we don't want print, sorry. Print game. There we go. Okay. Pretty exciting stuff. So let's look at classes here. This is part one. All right, so why don't we call it a day here? We'll meet back up for lab and practice writing some basic classes. Does that sound like a good plan? We'll start a little slow. It's okay. We'll start basic. Okay. All right, we've got a little bit of time. We'll finish it up on Wednesday then, right, for our classes bit here. It's not too much more we got to look at. All right, thanks, folks.